All right, welcome everyone. This is our talk on how to start your startup fast on Kubernetes. All right, first, of course, we need to take a moment to thank Denver Startup Week for hosting this for the 11th year. We also would like to thank our title sponsors, Amazon, Capital One Cafe, Dell for Startups, Downtown Denver Partnership.
Let me interrupt real quick. So we love sponsors. So everybody's got to do a sponsor slide. I just want to take a quick moment. We have been waiting for a really long time to be far enough along in our Kubernetes journey to talk as subject matter experts on the topic. And without our sponsors, we don't have this opportunity. So let's hear it for our sponsors. Yeah. It's so good, so good. Anyway, back to you, Jared. Back to you.
We also want to pay a special thank you to Denver Startup Week for hosting this event. And lastly, KubeShop for seeing the value in our open source project and sending us out here today. Quick disclaimer, by attending this session, you are agreeing to our code of conduct and being recorded. All right, so this is us, John and Jared. We started KubeFirst a little over 3 years ago. We've been helping startups adopt Kubernetes since about 2017 when we started working together. At the first company we were at, it was a real estate big data company. John and I found a good set of tools that was easy to get going after years of practice, of course, that we could then share with the world to give them that same kickstart to getting their Kubernetes journey going.
Yep, yeah. When we met, we didn't know Kubernetes at all. So for those of you that don't know Kubernetes yet, and maybe you're thinking about it for your next project, quick show of hands just for reality calibration. How many of you have already used Kubernetes at your place of work? Awesome. And are maybe thinking about it for a future project? Awesome, thank you guys. So when we started out on Kubernetes, it was immediate shock. In fact, we should probably talk about Kubernetes first. So Kubernetes is it gives you computing superpowers. It's a framework that appears complex at first glance, that allows you to run containerized applications in a well-orchestrated way. There's all these things that happen when you're running microservices architectures. You have to load balance your applications. You have auto-scaling concerns. You have to configure your applications differently for dev and prod environments. You have secrets to manage. You have all kinds of just stuff going on in a microservice architecture, and everything has to intercommunicate. And what Kubernetes lets you do is declaratively state the applications that you want and how many of them you want and how you want them to run. And Kubernetes deals with all of the other stuff. Make sure that it's well load balanced, it's redundant and fault tolerant, so when you have bumps that go in the middle of the night, you have a ecosystem and a framework that's automatically going to recognize, hey, it was supposed to be 10 instances of this app and there's suddenly 9, now there's 10, nobody got woken up in the middle of the night, no scripting involved, you're just using Kubernetes. Kubernetes is great. There's one really big problem with Kubernetes though, which is that there's this flourishing CNCF landscape of what we call cloud native tools. Now, cloud native tools are just tools that run really well in Kubernetes. Simply put, it's a little more complex than that. But each one of these applications, each one of these tools, will solve a problem in a microservice architecture. It might solve a secrets problem, it might solve a configuration problem, it might deliver your application from dev to stage to prod. But each one of these solves a problem, and your job, once you install your Kubernetes cluster, is to navigate this landscape to build out your platform, right? So that you can be delivering to production in a consistent way. So, we have some technical issues. Give us 1 second. We're back. So what we're gonna talk to you guys today, sorry, do I need to stand somewhere else? What we're going to talk to you guys today about is how to build a cloud-native platform in order from scratch, which once you have a Kubernetes ecosystem, it's going to be very easy to add another app. It couldn't be easier, but starting from scratch is terribly difficult. We're going to walk you through the first 8 steps that you have to do to build a platform for your startup. So before we get into it, we have a little bit of fun today. We've got some t-shirts. They look just like this. They feature our Stingray K-Ray here. Everybody loves K-Ray. If you want one of these t-shirts, we're going to do a quick little giveaway. So anybody in the audience, can you name a Git provider for a t-shirt? Let's hear one. Anyone? GitHub. GitLab. 2 great options. Let's stop with those 2. We'll get 2 t-shirts after those. Come meet us afterward in the lobby. We'll get your t-shirts. Infrastructure as code. Anybody? Terraform. Great choice. Great choice. Anyone else? IAM. IAM is a security and identity. CloudFormation. Yes, a cloud-oriented one. Very good. Say again? Pulumi. Very good. Very good. Anyone know a GitOps driver by chance? I know it's a little bit edge. We'll talk about this in a sec. Secrets manager. Anyone? Vault. Great choice. Artifact repository. Artifactory, great choice. Continuous integration? Circle CI, great. Authentication and authorization, any service that provides auth that you can think of? Say again? IAM it's definitely involved. There's also say again?
Ping identity.
Ping, yep. Yeah, there's Okta, there's Auth0, there's a handful of them. Observability, anyone got any thoughts on observability? Prometheus, great choice. Any SaaS observability tools? No? All right, sweet, that's great. Anyone that gave an answer, come grab a t-shirt. They're super soft, you're gonna love them. All right, so let's get into it. What we're gonna do today, I'm basically just gonna talk through as fast as I can these technologies. Jared here is going to show us a real example of an actual technology that implements that discipline on screen. So the first one we're going to talk about here is your Git provider. So Git, it's where you keep your source code in 2022. It just is. There's a lot of options, but you basically have 2. You have GitHub, you have GitLab. Now, they both do what the other one does very well, but there's a community of users that use GitHub for open source, and there's a community of users that use GitLab for very high privacy infrastructure. So if you're one of those 2, if you're an open source shop, choose GitHub. If you're very high privacy, choose self-hosted GitLab. If you're somewhere in between, flip a coin. They're both great products. And Jared, would you show us a picture of GitHub and GitLab real quick?
Yeah.
Should I hold the microphone for you?
Yeah, I'm actually just going to talk without the mic because it's going to be very good.
Can everyone hear me okay?
Actually, can you use the mic for recording?
I'll just hold it nearby. You can do your thing.
Okay.
Teamwork.
We'll figure this out. So here you have an example of what a regular GitHub repository looks like. This is an example of our GitOps repository that's delivered with our stack at the end. It basically holds onto your source code, and then it has other capabilities, as John mentioned, issue management, actions for pipelines, things of that nature. If you were to look at a GitLab variation of that, it looks very similar. You can see that there's some source code here. It's got that same README. It's going to have the same content from our platform at the end of the installation.
Awesome, thank you. And they both come in dark mode if dark mode is your thing. Let's move on to the next pillar. Next up, we have infrastructure as code. I heard Terraform earlier. Great answer, because Terraform is the de facto standard for infrastructure as code. Infrastructure as code is not an option anymore if you have literally any complexity about what you're doing. With Terraform, there are a handful of IAC providers. There's the older school ones are like Puppet and Chef, Ansible. Nowadays, it's mostly Terraform. There are A couple, Pulumi's trying to give Terraform a run for its money. What's nice about Pulumi is it lets you write in your developer's language of choice, so they can write their IAC in Golang or Python. HashiCorp Terraform is great though. If you're a startup and you're going to have any size about your apps, choosing Terraform will ensure that you can hire an IAC person to run your IAC, which is an important aspect. So hang on to Terraform. That's our advice for startups. Atlantis is a neat technology that allows you to automate that Terraform, which gives it the superpower of being able to provide a full audit log of everything that's ever changed in your system, who changed it, who approved it, all managed in Git. Crossplane is also neat, up-and-comer, works really well with GitOps-oriented architecture, which we'll get into in a second. So, Jared, can you show us an example of Terraform running in an automated fashion, if you would?
Oh boy. All right, so this is an example of what Terraform code looks like. It's written in HCL, which is the language that HashiCorp developed for it. This is an example of an S3 bucket being created. This one's very simple. It's just for Denver Startup Week. The nice thing about this is that automation and the audit trail that John was talking about. When your developer comes in here, or cloud engineer, or whoever, it makes that merge request available. Atlantis is automatically going to respond, and it's going to drop this comment on the merge request here. And there's a little bit of output at the top, so forgive the scrolling to the important part. Those are all no changes. But once you get to this nice line here, you see that this is the S3 bucket that we were just talking about. It's called K-Ray Denver Startup Week for a demo. And then if you continue down, it shows you all the configuration options. But most importantly here, it's going to say that there is one resource that's going to be added to your cloud. Nothing's changing and nothing's being destroyed. To apply this, you would simply come down here and drop a comment on this merge request that says Atlantis apply, and make that comment, and it's automatically going to trigger that automation to kick off and create that S3 bucket.
Thanks, Jared. All right, moving right along, let's talk about a GitOps driver. Now, GitOps sounds familiar to probably all of you, but you probably don't know exactly what it is because it's sneaky like that. So GitOps is a marriage between your Git provider and your Kubernetes engine. Kubernetes is very, very efficient and effective at taking files that represent a desired state of what you want in that Kubernetes cluster. And if you add a GitOps driver and set up a Git repository with all of those desired states in a single Git repo, then you suddenly have asset management for everything in all of your Kubernetes clusters, in all of your environments. It's a beautiful, beautiful architecture. What's really nice about it is it allows you to set up your Kubernetes cluster to pull that configuration into it, as opposed to having a CI ecosystem that pushes changes into a cluster. So you no longer have that attack vector of your CI ecosystem. You instead have to keep the security of a Git repository at the forefront of your mind. And obviously you want to defend at depth and have additional layers of protection. But for the most part, there's nothing that can apply content to your Kubernetes cluster except for your GitOps engine, and as long as you bootstrap your cluster to pull that configuration into it, you have a great security story with no scripting. No kubectl apply, no Helm apply, no Helm install, nothing like that. No engineers arguing about the right way to do, whatever. It's a lovely architecture. If you're going Kubernetes in 2022, you should do GitOps. Now, Argo CD is our favorite GitOps driver. It's the most popular on the CNCF with good reason. There's also Flux, and GitLab have variations. Flux was donated to the CNCF by Weaveworks. GitLab obviously needs no introduction. Open GitOps is a special interest group in the CNCF that is working to define the the definition of the discipline in a vendor agnostic way. So if you're not sure if you trust Argo or Flux or GitLab, go to OpenGitOps and study up on GitOps in a vendor agnostic way before you evaluate the tools, but they're all great options. So Jared, can you show us Argo CD real quick?
All right, so this is one of the applications that we deliver with our platform. Chart Museum, basically it's just a place for you to host your Helm charts. The nice thing about what Argo does once it pulls in that public Helm chart is it breaks down all of the Kubernetes resources for you in a nice visual way so that you can see what's running in your cluster. If you were to click on these, you would also be able to additionally see the YAML variation of how that was constructed. The last portion that John was mentioning, how it helps you with recovery scenarios is if you had, for instance, a developer accidentally come in here and maybe delete this application, we can see it, so sure. I can't type while I'm looking over my shoulder, sorry. So if you take a look at the screen there, it's gonna, that application is gonna completely disappear, and with no intervention at all, Argo CD is gonna be looking at that desired state, and it's automatically gonna put that application back into the ecosystem.
So there was just there. It dropped down to yellow, meaning it was missing according to the GitOps driver, and then immediately came back, and now you have the application there. It was gone for a second. So if nines are important to you in terms of uptime with your startup, they are important to you. Go ahead and buy into GitOps, and you get that disaster recovery that you just saw there for free. We didn't script anything. There's nothing running on a loop that we wrote or anything like that. Once you buy into GitOps, you get disaster recovery for free because the future is here. I'm not sure. So let's move on. Secrets management. How are we doing on time? 15? So secrets management is the unsung hero of your platform when you're starting out. When you think of secrets management, it's easy to think to yourself, well, the obvious scenario is the one where you have an application, it needs to connect to a database, you need to store that password somewhere safe. As long as you're doing that, you're doing secrets management, right? Yeah, a little bit. But there's all kinds of other secrets that are going to exist in your infrastructure. And you have to be postured so that you can replace those secrets, get the new version of the secrets out, and deal with any revocation scenarios when you have a new employee that wasn't working out and you need to drop them. You have a problem on your hands if they had access to a whole bunch of secrets. So you have to get that rotation up front early, and putting it in advance of your CI ecosystem allows you an option to have a place for all your secrets before you start getting into automation. And if you don't do that, those secrets will end up in your automation, and then you have a tech debt problem on your hands that you will literally never get rid of. So buy into a secrets manager, get it in early. Jared, can you show us just a quick visual of what Vault looks like?
Yeah, so here you have the HashiCorp Vault UI. This is the secrets portion. As you see at the top, there's some tabs of other functionality that's offered. If we were to take a look at one of these secrets here, this is a password for JD tier. This is the user experience that you would have to be able to update secrets. It's just a JSON object. You also have another viewpoint where you can copy secrets if maybe you're working in a coffee shop and you don't want to expose everything. As far as access methods go, we have a few that we leverage out of the box, but HashiCorp Vault has a ton of great features that allow for ephemeral credentials for many different types of things. That could be for your database passwords, for your OIDC provider if you end up using it for that, your Kubernetes auth methods. All these things are automatically rotating themselves, which is a great way to run your infrastructure.
It is free. They have an enterprise version. They also have a hosted version. But everything that we're showing you here is the free version of everything. It's all open source. They have a great open source offering. And it runs really well in Kubernetes as well. So next up is artifact repository. So this topic is going to vary a little bit shop to shop potentially. We don't know what language you're going to write your startup's application is. Whatever language it is will have output of some type of a package or a library. And if you need to host those libraries someplace so that other applications can also leverage that library, then you need an artifact repository to host that package in. Now, in a cloud-native ecosystem, you at least need one. You need a container registry because everything in Kubernetes runs in a container. So you at least need that one. We love the cloud ones for container registries, and we don't typically like cloud hosted content. We like cloud agnostic tools and technologies for the most part. But the cloud ones, you're talking like 6, 7, 9s. It's always up, it's always there. You never have maintenance on them. They're great for container registries at least. And depending on your technology, you might be able to leverage it for your application tools as well. The Git providers also have one, but in any event, look into your repositories, but you're at least going to need a container registry. Moving right along, there's no pretty pictures that come with container registries. They're super boring. So you're going to need a continuous integration layer next. Now that you have a place to store your packages, you need something that's going to be able to build those packages. And that's what your continuous integration does. When you make a decision on GitHub versus GitLab, you're making sort of a decision about CI as a default at least. GitHub has GitHub Actions. They're integrated really nicely. GitLab has a GitLab runner that runs in your cluster. Also very nice setup. We tend to like a third option though. There's an ability to run your CI in a Kubernetes native way, which is a fancy way of saying that it was a product that was written specifically to run in Kubernetes. Argo workflows, which is different than Argo CD, our GitOps driver that we talked about before. Argo has another product called Argo workflows that works really well at running CI in Kubernetes. It allows you to keep the blast radius of where your secrets are down to its bare minimum. And just everything, once you start adding stuff to Kubernetes, everything gets easier if it's in Kubernetes. So we love workflows. We're not going to die on this hill though. Everybody loves a CI tool. Whatever your developers want is what they're going to get. So good luck. Moving right along. Authentication and authorization. This is one where when you establish your auth story for your company, you're going to have to set up roles. Roles are inevitable. You hire people to fill roles, and the people that work in those roles need varying levels of access to the different parts of the system. So if you just think about it simply, there's admins and developers. Admins need a lot of access to the cloud. Developers need a little bit of access to the cloud. Same can be said for Kubernetes access or application access for tools that are on the platform. So you're going to have to set up your roles in 3 spots. It's going to go in your cloud, like I am, we heard before. It's also going to go in your IDP, which is your identity provider. Who you use as an identity provider is up to you. If you have G Suite, you already have an IDP in your pocket. There's also Vault can be used as an IDP, and there's the Oktas and Auth0s of the world as well. Nothing too fun to show you in terms of auth. We don't have anything for auth, right? Yeah. But just know that it needs to be set up in those 3 spots. It needs to be in your cloud, in your Kubernetes cluster, and it needs to be integrated with all of your platform tooling with reasonable access for the apps that run on your platform. And lastly, Jared, do you want to take the observability?
Sure. So observability is a really important part of the process for your developers as they're shipping applications. There's a couple of things that need to be watched. In addition to your in-house applications, all of your infrastructure and tools are going to need to also be monitored. That comes with a really heavy burden, especially if you're running all those tools yourself and you're self-hosting them. For startups, we usually recommend that you offload that burden to a SaaS provider. We always choose Datadog. Datadog's great. They develop features faster than we would ever be able to. They also have a better uptime, and it really removes a burden on the developers. It's easy to get up and running. The nice thing about Datadog, too, is that it gives you a ton of integration points. So if we quickly take a look over here at... this is one of the dashboards that you get out of the box just by deploying the Datadog agent. It's going to give you a breakdown of your Kubernetes cluster in this capacity and a lot of other details, but you can see that we're only managing this one cluster with this agent set. We have 17 namespaces and 68 pods. That means that at the end of our platform installation that we're showing you here today to demo all of this, there's 68 tools running in this cluster in 23 minutes. So it really does take a lot to be able to quickly develop and ship your applications. It also gives you some nice views. This one cluster here is running 7 nodes, which means that there are 7 virtual machines under the hood there that are actually hosting these applications. And when you break that down further in Datadog, you get this nice visual of what those containers and pods are doing on an individual level in each of those namespaces that are running within the cluster.
Awesome explanation. So if we can we stay on that screen for just one quick sec? So if you just look at this is just what it looks like to run all the containers that you need to do all the stuff on the platform that we've showed you today and no more. There's nothing else in this cluster. So that's, if you look at that right there, that's 68 things that you need to keep track of, 68 things that can go wrong, 68 things that you need to monitor, that you need to set up alerts for potentially. The ability to just offload all of that to a SaaS ecosystem is really important for a startup. You can replace this. You don't need to buy into Datadog permanently. In fact, you don't need to on day one. But what you would have to install to replace Datadog is, you could go with another SaaS provider. There's New Relic is a great one. AppDynamics is a great one. We love Datadog. We think they're the best. But if you're on a shoestring budget, you might hear, well, we can just run, we can self-host our observability, and you can. The problem is when things go wrong, you need that observability to figure out what things went wrong, right? And if part of your platform is self-hosted observability, and that self-hosted observability is what went down, then you have a little bit of a chicken and egg problem on your hands. So to replace all this stuff would take, you would need Grafana, Prometheus. Grafana's for dashboarding, like the initial dashboard that Jared was showing us with all the pretty pictures. You have Grafana, you have Prometheus for metric emission in Kubernetes. You have Jaeger for tracing. You have the Elk stack for logging, so you need Elasticsearch. You need Kibana. We're talking about a lot of different tools, and frankly, your engineers are going to be busy. So offloading that burden for the first year, really great advice for a startup. If you're hell-bent on self-hosting it, do it in year 2 and give yourself that first year to get the platform established, get everybody using the same tools the same way, and then transition to something self-hosted. You can self-host all the same stuff Datadog does. It just takes a lot of effort. That's your first 8 steps for a platform. Jared, do you want to recap everything for us?
Sure. So just to recap the 8 things that we talked about here today, we need to establish a Git provider, put your infrastructure as code in Git and make sure you automate it. That's the really important part. When you have developers all running Terraform on their local hosts, sometimes somebody makes a change that breaks another developer's, and then you never know who broke what. Just turns into a big mess. GitOps with your secrets management. Make sure you have that set up early. Terraform your artifact repositories. GitOps your CI system if you choose a cloud-native version. Terraform your authentication and authorization. And GitOps your observability.
Some scenarios to avoid. You have to avoid these, seriously. This is the time to pay really close attention if you didn't take a photo of that last screen. So don't establish your CI without a secrets manager. We talked about that. Your important secrets will end up in that CI ecosystem. Don't start scripting, leverage GitOps. That's gonna sound weird, but once your engineers get into GitOps, it makes perfect sense. You just declare it in your GitOps repository in state in YAML format, and Kubernetes and the GitOps engine will just make it reality with full disaster recovery and all kinds of great stuff. Don't run local Terraform, automate it. Terraform is a command line tool. cloud engineers love running that tool on their laptops. If they're running it on their laptops, their other engineers don't know what they're doing, when they're doing it, who approved it, etc. So get that in early, automate it early, so that you can start building that full audit log of everything that's ever happened in your system. And don't delay on single sign-on. You're going to have engineers leave. You're going to need to be able to revoke their access super fast. Single sign-on up front is a must.
So for this Terraform, where do you keep the state then? How do you run it if you don't run it locally?
So the state belongs in, all the cloud providers have some kind of a S3 bucket type of storage, and Terraform, you can keep the state in that cloud storage.
You run it from the GitLab runner then, for example.
That's correct. So we typically automate it with Atlantis. Atlantis is a webhook based system where when a pull request gets submitted to your GitOps repository in GitHub or GitLab, that'll invoke a webhook. Atlantis will wake up, it'll run the plan, send the plan back to your Git provider. If the plan looks good, somebody types Atlantis apply. That, again, it's a webhook out to Atlantis. Atlantis conducts the execution. If it's successful, it'll automatically merge, close the pull request, and apply that infrastructure's change. If anything fails, it stays in a pull request open state so that you have an opportunity to push an update, and you kind of fight with Atlantis until the Terraform says, yeah, okay, everything's good, it went through, it applied successfully. And you get to see those fights when you automate it in Atlantis in a way where, like, you don't see those fights when it's on an engineer's laptop. So.
And why Atlantis and why not HashiCorp's hosted?
You certainly could. So HashiCorp does have a hosted solution. It's a SaaS offering. They call it Terraform Cloud, yeah. And it's another great option. If you wanted to offload that burden of automating and running your IAC on your platform and just wanted to have it run in the cloud, HashiCorp Terraform has a great cloud SaaS offering for that. And that's our talk. So hope you guys, do we have time? We have maybe another minute for questions. Yeah, go ahead.
That's a question. So these days, most of these things are deployed in cloud, right? I mean, heterogeneous scale. I mean, all we talked about is great, but AWS really has all the built-in. Again, the whole CI/CD pipeline, entire thing is built in, right? With observability. So why would you want to go and pick out pieces of these other pieces, and then you need to have integrate that thing, right? Open source is the version change, right? Somebody pushes out a new version, suddenly you nightmare trying to manage all of this version to work correctly. And this is argument that AWS can say, one page, everything is done.
That's right.
I mean, so you can put your time on application development, not on trying to build the infrastructure.
That's a really good question. So the question, in summary, is why not buy into the cloud specific version of whatever the discipline is? And you certainly can. You have a decision to make on whether or not you want to handcuff yourself to that cloud provider. If you're okay handcuffing yourself to the cloud provider, those tools are, God, do I put my opinions on the table like that? So what I will say is the cloud native ecosystem is like nothing I've ever seen before in computing in IT. I mean, it's a flourishing environment of everybody working toward a singular vision of how to run microservices and containers. And the products that come out of that are just great. And I can't say the same for, say, a specific cloud provider's CI implementation or a cloud provider's, I don't know what another example is. A cloud provider's secret manager, if all you have are simple secrets, that's a fine approach. You can keep secrets in a cloud, and you would not be using a cloud agnostic one, so you couldn't pick it up and take it to another shop. But you're talking about flat secrets, right? Just access to databases or whatever. And if your implementation is that simple, that's a reasonable way to go. It really is. So I hope that helped answer the question. Yeah.
If you were to spin those up on, say, AWS, what would your monthly cost be?
So to run this cluster that we were showing you today, it costs about $7, $10 a month.
$10 a day.
I'm sorry, $10 a day? Sorry, a month. Yeah, that would be amazing. Oh my goodness, I would never stop running infrastructure. Yeah, it costs about $10 a day-ish for about and that cost is a AWS EKS-oriented cluster implementation. So you're talking like EKS plus 7 nodes to run that cluster, plus a little bit of sugar for your let's see, you're going to need a VPC, you're going to need some S3 buckets, a little bit of Dynamo for your secret storage, and some KMS to keep it all encrypted, but KMS is free. So it's not very expensive. It's about, I guess, $300 a month. Yeah. Or no, I'm sorry. Yeah, I did that math right, $300. Never do math in public. What am I doing? Any other questions before we wrap up? Right here?
Can you expand on your point about don't do CI without a secrets manager?
Yes. So if you have a secrets manager, let's say you had a secrets manager like, let's pick on Jenkins, okay? Everybody likes picking on Jenkins, right? Poor Jenkins. So in your Jenkins ecosystem, you have to write a script that's going to publish a Docker container and publish it somewhere. That somewhere you need access, right? You need some kind of password. If it's Docker Hub, you need a username and password or some kind of a access key. If you don't have a secrets manager, then you are forced to put that secret somewhere. And the natural spot for it is your CI, right? All the CI tools have a secrets section in them where you can keep that Docker Hub password safe, and it is safe. But it's also in your CI tool. But that's not the only thing that's going to need that password. Something else is going to need it, right? And so before you know it, you're going to have multiple sources of truth depending on the technology that needs to implement that secret. So our stance is if you buy into Secrets Manager upfront and establish that singular source of truth, then it has to come with a policy to also not use the CI secrets management, as well as the cloud secrets management, as well as all the other places that secrets have to go. You get that opportunity to set that up front so that it can become the singular source of truth for your secrets. So that's really all we're trying to indicate there.
I just had a quick one.
Yeah, let's have it.
I noticed there's one missing from the Git options, which is the Atlassian suite.
Oh, it came up. It came up. It's a great call out. So there are a lot of Git providers in the world. If you need a tiny little provider for Git, SoftServe is a great option. There are other SaaS options in the world and self-hosted options in the world. Atlassian has one called Bitbucket. I've heard rumors that it's okay. But to stand up here and tell you that it's a good standard to build your company on, I don't think I have that in my heart yet. But I also haven't experimented with it quite enough to have any voice of authority on Bitbucket. So, anyone else?
What's the lowest dollar figure you could put per month at this, and you achieve something like what you're talking about?
Lowest dollar amount.
Don't have a good answer for that.
When you say that, are you talking infrastructure costs or also the engineering costs to build the platform out?
Total dollar. I mean, on the other side of town, we've got some of the underserved or struggling to get funding types, and they might like to have some of these things.
Absolutely.
And what you're going to do is, as you're the developer for them, I'm sorry, you can't afford that.
I know.
You're going to have to make compromises, and it ends up someplace else.
Yeah, so there's a couple ways to answer that question. There's you have opportunity to build on Kubernetes on your local host through tools like K3D or Minikube. You could run and build a lot of this infrastructure without the cloud cost. So if you have a laptop and you can install these local Kubernetes ecosystems, then you can get started without enduring the initial cloud costs that you have. But the cloud costs are inevitable. You have to run this thing in a cloud somewhere. DigitalOcean is a very good, cost-effective way to run a Kubernetes cluster. I also hear that there is, what was the one that we were hearing the other day? Had the no, not Linode, although that's another good inexpensive one. I think it was IBM's cloud had at least an offering where you could get some nodes for free. But at the end of the day, it's going to cost money to run a cluster of this capacity. You can't get away with running it for any less than, I wouldn't think, a couple $100 a month. So. Which is not inconsequential.
It's not a bad answer. At least you know.
Yeah.
You'd be worse off going and working with the shoestring budget.
I know.
Getting halfway there and wasting all their time.
No, I know.
Yeah, and go ahead.
Can I comment on that? Because there's also like Coursera where you can do courses for a small amount per month. And then you can run, for example, in Google, you can run your Kubernetes clusters. So there's,
I'm sorry, what was the name of the first one you mentioned?
Coursera.
Coursera.
It's free, right?
Gotcha,
You
okay.
can do a course and then you can run the resources in the cloud.
Right on, right on. All right, guys, well, I think we've overextended our stay by a handful of minutes. Thank you guys so much for the participation. Come meet us outside and grab your t-shirts. It's been really great having a microphone at long last. Thank you guys so much.